Dihybrid crosses and the product rule. You've already learned how to do monohybrid crosses. Examples like this. Long fur is dominant over short fur. If two long-haired cats that are heterozygous for fur length mate, what is the probability their kittens will have long fur? To calculate this, you set up a Punnett square by putting the alleles for each parent outside of the Punnett square, one across the top and one down the side. Then complete the Punnett square by filling in with the alleles that are above and beside of each square. Then you can determine the probability the kittens will have long fur. You know long fur is dominant, so the boxes inside of the Punnett square with a capital H indicate offspring combinations that would create long fur. This means there's a 3 out of 4 or 75% chance that an offspring will have long fur for these two parents. But what if you were asked this question? Long fur is dominant over short fur. Dark points, like the dark face, ears, legs, and tail of a Himalayan or Siamese cat, is recessive to having a solid body color. If two parents with the following genotype breed, what is the probability their offspring will have dark points and long fur? Now, instead of completing a monohybrid cross, we've been asked to create a dihybrid cross, or to determine the chance of two different traits being inherited together. What do we do? To solve these, we can use the product rule. The product rule states the probability of inheriting unlinked genes together may be calculated by multiplying the probability of inheriting each gene separately. One important thing to notice here is that the requirement is that the genes must be unlinked. This means that instead of the genes being on the same chromosome as seen here, the genes need to be on different chromosomes. So the gene for the dark points and the long fur would have to be on two separate chromosomes. When this is the case, the product rule can be used. Let's return to our problem. Remember, the product rule said we can find the probability of each trait separately, then multiply those results together. So let's set up two Punnett squares now, one for fur length and one for color pattern. We are then going to take the parents' alleles for fur length and for color pattern and add those to the appropriate Punnett square. Then complete the Punnett square, first for fur length and then for color pattern. Now let's go back and look at what the question is asking us to find. We are being asked to find the chance of offspring having dark points as their fur pattern. If we look back, dark points are recessive. So when we consider our Punnett square, 2 out of the 4, or there's a 50% chance of the offspring having the dark points. Then we look at the next part. What is the question asking us about fur length? We're looking for the chance of offspring having long fur. Recall that long fur is dominant. So all three of the boxes that have a capital H, whether it's homozygous, dominant, or heterozygous, are going to have long fur. That's a 3 out of 4 or 75% chance of long fur. Now, to determine the chance of these two traits being inherited together, we simply multiply the results. 1/2 times 3/4. When you multiply fractions, remember to multiply straight across the top and straight across the bottom. 1 times 3 is 3, 2 times 4 is 8. So the probability of the offspring inheriting both dark points and long fur is 3 out of 8. The product rule can be extended for any number of traits as long as these traits are unlinked, as long as they are found on separate chromosomes.